Hello everyone, welcome to Drishti IAS in this new series which is related to your 100 most important topics for your Prelims 2026. As you know that we talk about lots of the topic, and inside this video we are going to talk about these two very important topics. The first topic is nuclear science, where we are talking about the fission and fusion reactors. You know that fusion reactor have a program which is known as ITER. And also we talk about the India's three-stage nuclear program, because it is currently in the news, because now India gaining the second stage final round is completed for us. Now we are going to talk about missile system also, where ballistic system, cruise missile system, hypersonic vehicle, and our indigenous system like Agni and BrahMos. So let's talk about all of them. So the first part is your nuclear fission reactor. As you know that we have two kind of the process for nuclear energy, the fission and fusion. But actually in India and in the world, all the reactor which are providing you the commercial energy, they are based on fission. Basically we are using the uranium, break down uranium and find the heavy amount of energy. You can see this is the nuclear fission reaction, and you are using the uranium-235. And by inserting a neutron into it, the nucleus is exploded and we find the barium and krypton. After that, 3 neutron particles are come out as a product, and also we form lots of the enormous energy. And this can be based on a chain reaction. Chain reaction means you can do it in a controlled manner, and for this controlled reaction we need a proper reactor. So basically this fusion based reactor that we have. So inside of this reaction, 3 neutron are come out and we can absorb the 2 neutron. So 2 neutrons are absorbed. And this absorption can be done by two kind of the rods. They are known as the control rod for a nuclear reactor, made by the cadmium and boron. So basically by using these rod, we are having a reactor where controlled chain reactions are running out and they can provide you the sufficient energy. So this is basically your nuclear reactor. So this can be based on a chain reaction, but you know that this can be controlled. This can be controlled reaction, but if this reaction is uncontrolled, and that result is known as your atomic bomb. So actually this atom bomb is based on your nuclear fission reaction, but that is uncontrolled. But controlled in manner provide you the basic energy. It releases the large energy, approx 200 mega electron volt per fission. So every time this can be exploited, provide you very high amount of energy. But the problem is always radioactive waste. If I tell you in a very simple way, the radioactive waste which is come out after the uranium use from a reactor, this can be radioactive almost 10,000 years. And that's why we can say uranium is a very problematic thing, because this can provide you energy, that is a better perspective. But the radioactive material which can be rested after its use, this can be very dangerous. So this is a highly radioactive waste production. Also it is used for your nuclear power plant, and these power plant provide you the current, or maybe we can say electricity. This can provide you the electricity. This can be also uncontrolled in atomic bombs. But if we talk about the Indian reactors, so in India, we are using mainly in the PHWR. In current days, if we talk about till date, we have 24 running reactors. But out of this 24 reactors, 20 reactors are your PHWR. Other one is your BWR, HWR, FBR. Lots of the reactors are there. But actually the one that is called your PHWR. PHWR means pressurized heavy water reactor, because every reactor needs a coolant and moderator, and we can use the heavy water for it. So this one is pressurized heavy water based reactor, and that we have almost 20 running till date. So as per the information in March 2026, we have 20 running reactors PHWR, and they all are based on uranium, which fulfill the maximum part of electricity demand of India. So this is your fission reaction. But one point is also there. There is uranium, we use it, but also we can use one more thing that is called plutonium. So uranium-235 is our fuel for fission, as the same way plutonium-239 is also used for the fuel. Clear? But in India, we are using this one in current days. Futuristic approach can be related with your plutonium also. We talk about it. So, second one, if we talk about nuclear fusion, as I tell you, nuclear fission and fusion, when you compare both of them, fission provide you heavy amount of energy, but in compared to fission, fusion provide you very high amount of energy. This energy can be higher than the fission energy amount, but no country, also India, cannot have any fusion reactor which provide you the commercial energy. Although we have one experimental reactor, and that is placed in the Plasma Research Institute, Gujarat. So basically we are having a one reactor, but that is only experimental, because fusion reaction are totally different. In this fusion reaction, we cannot put the neutron. Although the inserting thing, or maybe we can say the input, is our temperature. So very high temperature that can be given to this kind of the reaction. And this temperature is not a normal temperature. This can be a temperature where everything can be converted into plasma state. You know that plasma state is the fourth state of matter, where even the atomic structure cannot be present. So basically in a fusion reaction, we are doing a very different concept. We are taking hydrogen substances like 1H2 and 1H3 we are taken. They are known as the isotopes, deuterium and tritium. So we take the deuterium and tritium and we can give it a very high temperature, almost 10 to the power 6. And this very high temperature almost break down this hydrogen molecule, and electron, protons or neutron, they are come out in the space. And then after that, they can combine and form a new molecule that is called your helium. So basically new atom is formed. This is your fusion. So by breaking the hydrogen, you make the helium. This is your fusion reaction. First you break, then you add. That's why you called it fusion. So very high amount of energy is there, and that's why there is a heavy mass destruction. And this mass destruction provide you very high amount of energy. The energy is too high, and that's why this fusion reaction is also called as deuterium and tritium the fusion, because we are using these two things. So when we talk about its feature and the benefit, it required the extremely high temperature that I tell you. This is the temperature almost related to plasma, and this is a very, very dangerous point also in this reaction. Or maybe we can say this temperature provideness is the critical stage of development for fusion reaction. But there is no chain reaction. That is again a very important point. It can produces the clear or energy because the radioactive waste is very less. Yes, this is the major important point. And why the world and India also willing to make a fusion reactor? Because the waste material which is come out after this can be less radioactive than your fission one. That's why we talk about, if the example for it, so the primary energy source of the sun is your fusion, because you know that for making this type of the fusion reactor is something like that you are developing a sun, because the source of energy in the sun is also the fusion reaction that can be present between the helium and hydrogen molecules. For this purpose, development of any type of the fusion reactor is a very tough task. This is very expensive, and that's why many countries came together and talk about the development of the first commercial energy production fusion reactor. So this project is known as your ITER project. It is based on a fusion reaction research. So basically what is the overview? So full form of ITER is your International Thermonuclear Experimental Reactor, and there is many partners. Totally the partner members are India, European Union, USA, Russia, China, Japan and South Korea. So total 7 members are there, and these members are including with India want to develop a common infrastructure of fusion reactor. This one is the first commercial fusion reaction based reactor in the world, and we want to develop it in the location of Cadrech, France. So they are the partners. They are providing some technology by the partnership. They cannot provide the fund, although the technology partnership are there. India is also the member of it, and this type of reaction is known as your tokamak reactor. So basically fusion reaction reactor is known as tokamak reactor, and we want to develop our first one in Cadrich, France. So what are the key contribution given by the India? So India is providing two things. Basically the cryostat, which is your cooling system of your chamber where the reaction can be done. So RF heating system and your cooling system cryostat. Cryo means you know that very low temperature is there. So manufacturing by the Larsen and Turbo critical water cooling system, advanced RF heating system. This is the partnership base. So RF heating system that can be given by your India. Always remember ITER project is one of the most important project, and the development of infrastructure of this that can be completed in 2025, and it is expected that this can provide you the commercial energy by 2035. What are the best feature? Because the input is there, you have first provide the energy, then it provide you the energy. Input is very high due to the temperature, and that's why we can say you provide the 50 megawatt, you provide the 50 megawatt energy, and this one provide you the 500 megawatt energy. So 10 times more energy provided by the fusion reactor. So this is the approach, and this may be gained by the 2035. This is the target right now. It is your ITER project. When we compare the fission reaction with fusion reaction, so you know that fission is based on splitting the nucleus, but fusion is based on joining the nucleus. Fission reaction, fuel is always uranium and plutonium, and in this part we are using the hydrogen isotopes, that is your deuterium and tritium. Low temperature is needed because no investment of temperature is there, but this one using very high, extremely high temperature. But high radioactive waste is come out in your fission reaction, but low in your fusion one. What is the status? Fission reaction can be commercially used currently. All the reactors provide you commercial energy. They are based on fission reaction, but this one is only experimental, that is your ITER. But what are the risks in your fission? This can be melt down. It means if you cannot properly cool down your reactor, this can be melt down. Very big risk, but this one incomparatively safer. But we cannot have this one. We want to develop it, and in futuristic approach maybe we can have this one. Now we are going to talk about the India's 3-stage nuclear program that is given by the Dr. Homi Jahangir Bhabha. So around the 1950s and 1960s, Dr. Homi Jahangir Bhabha want to do one thing, that India have to be make itself self-reliance. Because if we are always dependent on the uranium, we have high investment cost, high purchasing cost of the uranium. But India is a huge reservoir of thorium, and you know that thorium is also a radioactive fuel. When we talk about the fuel for nuclear reactor, this is of 3 types. First one is your uranium, second one is your plutonium, third one is thorium. And when we talk about the thorium, so India is the first heaviest reservoir of thorium. Almost 25% of the thorium of entire world that can be present only in India. So Dr. Homi Jahangir Bhabha want that first you start from the foreign help, because they have the critical type of reactor based on uranium. So first you can start from that, you depend on the foreign help, but one day you have to make yourself self-sufficient in energy sector. This is your 3-stage nuclear plan of India, and this is very, very important right now, because previous some days, although maybe we can say before 10 days, we have achieved the 2nd stage of it, and that can be very, very important one. So if you talk about these reactors process, the first one, first stage, this can be based on your PHWR, and this PHWR reaction type is totally based on foreign help because they are uranium based. You can see the natural uranium 238 and 235 is the mixture, which is the fuel. Why you put the uranium 235 with your uranium 238? Because you are using energy formation by 35, and after the transmutation process, because lots of the neutrons are come out, So basically using the neutron, you want to convert this 238 into plutonium because plutonium is 239. But in this type of reactor, already I tell you we are using the heavy water. That's why we called it pressurized heavy water reactor. And what is the process? It produces the plutonium 239. This is very, very important. So in the first stage, we are totally dependent on the foreign help. PHWR reactors are there. We are using uranium 235 for energy, converting uranium 238 into 239 plutonium. Then this plutonium is used in your second stage, and we are now fixed into the fast breeder reactor. And you know that India's first fast breeder reactor, which is basically a prototype, that is present in Kalpakkam, Tamil Nadu. So India have this one prototype of it, and inside of it we are doing the research of plutonium thorium research. And this one is your plutonium 239 that can be used. We have a Kalpakkam fast breeder test reactor, so we have only the test reactor, and our test reactor is gaining the criticality. It means now we are completing our second stage. So finally India done this. That's why this project is very, very important one. So now India is entered into this second phase, and we are gaining the criticality of FBR. It means your FBR is a very, very special one. Why it is a special one? Because it is a breeding one. Breeding means it produces the more fuel than it consumes. You know that in Mahabharata there is a word that is called Akshay Patra, where you can put something in the patra. This can provide you a very high amount of substances, but they will never be ended. And this FBR is doing the same thing. How? The first stage plutonium is used as a fuel, but you can use uranium 238 with it. It means uranium 238 it mixed with plutonium 239, and this plutonium provide you energy, and again by the transmutation your uranium is converted into plutonium again. So this reactor is very special one because it uses the plutonium but also provide you the plutonium, and the breeding ratio is 1:3. It means it uses 1 gram of plutonium, provide you 3 gram of the plutonium. 1:3 is the breeding. It means this can be never be ended. So plutonium never be lapsing for utilization. So this is very, very important one, and it convert the thorium uranium 238. So the first stage we form plutonium with plutonium, and when lots of the plutonium we can gain, then we use our thorium. So basically the first part of second stage have two part. First you can use the plutonium, gain the plutonium, then you can use the plutonium with thorium for making this uranium. And this one is rested, but the first part gaining the criticality that we can over up. So India can achieve this one, and after this achievements we are more eagerly towards the self-sufficient energy sector. So basically now we are going to talk about the thorium conversion into uranium, and when you can gain the uranium, this can be used in your third stage. So third stage, there is a thorium based reactor is needed, where uranium 233 is used for fuel, and this one is derived from your thorium. So basically second stage convert thorium into uranium, and this uranium is used in your this part. And this is the India has the world largest thorium reservoir, 25% thorium that can be present with India, and this can be sustainable energy provider for India. So you have to remember before your examination that India gained the criticality. Our FBR reactor, which is placed in Kalpakkam, they provide you the breeding, they use the plutonium and also provide you the plutonium. Clear? This is known as your breeding. So this is called as the 3-stage nuclear plan of India. Now we are going to talk about the next thing. This is known as your ballistic versus the cruise missile. So missile system offer, and you know that what is the ballistic missile and cruise missile? If I tell you in a very simple way, so your ballistic missile is something like that. Ballistic missile is like that which can follow always the parabolic path. Ballistic missile can go like this. This is your parabolic path. But cruise missile is always cover the distance parallel to the surface. This can go parallel to the surface. And that's why we can say the cruise missile always in control. This one is controlled in the path. This one can change the path. This one can fly near to the Earth's surface. Tough to catch with radar system. Air defense system is not easy to detect it. So these are the benefit with your cruise missile. But ballistic missile is the older version, or maybe we can say the basic missile version. One path is there. This can be easily identified by the radar, and that's why interception of ballistic missile is easy in compared to cruise missile. So when we talk about our ballistic missile, so they can always follow the parabolic path after the boost phase. Once you launch it, this can be go in its own path. So when we talk about the key features, this can also travel exo-atmospheric travel. It means outside of the atmosphere it can travel, because the height it can gain is very high. It can go with a very high speed, you know that, more than 5 Mach speed. So this one is basically hypersonic in nature. Hypersonic means more than your 5 Mach speed. It is capable to carry the nuclear warhead. What is the example that India have lots of the variety of ballistic missile? Our first one is your Prithvi, Agni, and your K series missile, basically your Karam series missile. And these are having your nuclear weapon. So N means nuclear weapon can be present with this. So Agni, Prithvi, K series and Dhanush missile. So these all are basically present with the nuclear weapon, but also we have the Akash, Nag, Pralay, Prahar, Shaurya, Astra, many type of the ballistic missile that we have. But you know that when we talk about the cruise missile, this can be fly within the atmosphere by using the jet engine. This one is a very important point. This one is using the jet engine, and due to this engine you can control it in any mid path. This can be guided and low altitude, not gain too much height. So we can say they can be terrain and hugging in the path, means they can change its path in during the flight. But this one have a very high precision. High precision, why? Because you can control it. The radar eversion capability is there. It means this cannot be easily detected by the radar, and this can be your subsonic and supersonic speed. Subsonic means less than 1 Mach, and your supersonic means between 1 Mach to 5 Mach. So speed of sound less than speed of the sound, that is your subsonic, but 1 Mach to 5 Mach means 5 time up to the 5 time speed of sound. This can be supersonic, because more than 5, that is hypersonic. The ballistic is hypersonic, this one is supersonic and subsonic. India have 2-1. By the Russia help, we developed the BrahMos, and indigenous development by DRDO, that is your Nirbhay. So we have these two. Now, if we talk about comparison between the ballistic and your cruise missile, the path, you know that this is your parabolic path in ballistic and guided path, a straight line in your cruise. The speed of ballistic missile is very high, but this can be moderate to high, because this is subsonic and sonic, or maybe we can say supersonic. This one is hypersonic. The altitude, space and atmosphere, means it can go up to the atmosphere, but this can fly into the low altitude. When we talk about the accuracy, the ballistic missile accuracy is very low, but very high accuracy by your cruise missile. Detection is easier in ballistic missile because the path only one, but it is hard because of change in path capability. The engine, the rocket engine, means your solid fuel or liquid fuel engine can be used, but the jet engine is used in your cruise missile, and who can provide you the better control over it. UPSC also asked the question from this point, so you have to remember all the process. Hypersonic vehicle and India's HSTDV, this is the program of India for the development of hypersonic vehicle. So when we talk about the hypersonic vehicle program, so basically there is hypersonic word, it means you have to develop a missile that can have the speed more than 5 Mach, and this can be only founded by using a jet engine, and we are using the scramjet engine for it. So the extremely high speed and maneuverability is also there. This can change in path. difficult to intercept by the current missile air defense system because the speed is too high, and by the speed you can basically glitch with the air defense system method. So it can change the trajectory between the path. And there is India's hypersonic program. This one is known as your HSTDV, Hypersonic Technology Demonstrator Vehicle, that we want to develop, and this can be developed by your DRDO. We are using a scramjet engine for it, and India successfully test its hypersonic missile system. So we are enter into the club. Clear? Next point. When we talk about the indigenous missile system, so the perfect best one, that is your Agni series. We talk about many things, but we have the best one, that is called Agni, because Agni 5 is the latest one, which is very famous, and UPSC also asked the question from Agni 5. So this is ballistic missile development by the DRDO, and you know that India have a program called Integrated Guided Missile Development Program, that is started in 1983 under the guidance of APJ Abdul Kalam Sahab. And by this we develop Prithvi, Agni, Akash, Nag. These missiles we develop, and this can be the most important missile. Variants are there: Agni 1, Agni 2, Agni 3, Agni 5. This one is now very famous one because it is the latest one. Why it is the latest one? Because Agni 5 have more than 5,000 kilometer distance capability, and this is India's first. This is India's first intercontinental ballistic missile, ICBM. It is India's first ICBM. 5,000 kilometer, it cover the continent. That's why we can say intercontinental ballistic missile. So this is the most important one. What are the key features? This is also capable for carrying the nuclear warhead based on the solid fuel propulsion. This is also a very important strategic point. You know that if we talk about the missile system based on solid fuel and liquid fuel, the solid fuel is always best, because you can make a missile with solid fuel ready to launch. They can be always filled with solid fuel, and they can be placed in one point, and they can be ready to launch. You can set it as a ready to launch position. But liquid fuel missile cannot be ready to launch in position, because you can put the fuel only when you want to launch the missile. Before, you cannot put it for ready to launch. Clear? So we can gain the benefit, and that's why we have this Agni series, very important one. This can be road and rail mobile launches. You can launch it from anywhere. So basically Agni series status, it is the forming the backbone of India's nuclear deterrence. That's why we called it the most important one. Next one, your BrahMos missile. This can be by the help of Russia. So it is the joint venture of DRDO and Russia, and we give it a name of BrahMos by the Brahmaputra and Moskova river, and by mixing of this we make it BrahMos. So actually this is India's first cruise missile by the foreign help. It is launched from the land, sea and air. This can be launched from anywhere and having a speed of supersonic. Already I tell you, less than 5 Mach. So less than 5 Mach speed is there, supersonic group is there. So this can be very important one. We can have the capability to launch it from land, sea and air, and not only from the sea surface, we can launch it from the submarine also. So in sea, we can launch it by two places, submarine. We can launch it by the submarine also, and also we can launch it by the ship. This is the capability, deterrence power, this BrahMos. When we talk about the key features, this one is based on your fire and forget system, means a highly accurate system. This can be almost 100% target based system. So it is operated automatically after the launch. So very high precision. It is capable to surgical strike. Once you lock the area, this can be hit that area. It is the fastest in the class. It means it is the world's most rapid cruise missile. So best in that. The advanced version of BrahMos, that is called BrahMos 2, that can be belongs to the category of hypersonic. This is currently under the development. It means we have tested this technology and now BrahMos 1 is your supersonic one. Now we are entering towards the hypersonic club, because you know that in the previous slide we know that India has successfully tested the hypersonic system, and by this India want to develop BrahMos 2. This is under the development condition. Clear? So this is the topic, and now we talk about the questions related to it. And as I tell you, UPSC asked the question from missile also and for your ITER project also. So in 2016, there is a question. This is based on your ITER project. This is based on your ITER project. So basically, it can use the thorium in place of uranium. No thorium, no uranium, based on hydrogen. It attained the global role in satellite navigation, no role with it. It can improve the efficiency of fission reactor. This is not a fission reaction. This is a fusion reactor. It can build the fusion reactor for power generation. Yes, this is the correct statement. So in 2016, ITR question was there. This one is the answer. One more question that can be asked in 2023, and this is your missile system based question. So first line, ballistic missile are jet propelled and subsonic speed, while the cruise missile rocket powered only in the initial phase of the flight. So you know that this one is a wrong statement. You have the more than 5 Mach speed ballistic missile, hypersonic club. You know that supersonic and subsonic are your cruise missiles, but hypersonic club you have the Agni 5, and that will be your hypersonic. So this is a wrong statement related with your ballistic missile. When we talk about the Agni 5 is a medium range supersonic cruise missile. So this statement is also wrong. Agni 5 is your ballistic missile, which is your India's first ICBM, intercontinental ballistic missile. This is not a cruise missile. So it is also a wrong statement. BrahMos is a solid fueled intercontinental ballistic missile. So this is a wrong statement. Actually, this can be misplaced. BrahMos have to be placed on this one, and Agni have to place on BrahMos word. So you can interchange, then this statement is right. So in 2023, both these statements are wrong. This question asks about the current statement, but neither one nor two. So this is something related to your missile system and your fusion and fission reaction. Clear? I also provide you two questions for your practice. So this is your first question, present on 3-stage nuclear program fast breeder reactor. And also I provide you one more question. This is also related with your BrahMos system and missile system. Clear? So after watching this video, you can clear your concept and read these questions, and you have to give the answer after this video in the comment box. So thank you for watching. Thank you very much.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.